Hi everyone. Today we're going to study inverse Z transform. The inverse Z transform is written as with this symbol. Capital Z is raised to -1 exponent. This is the inverse Z transform of the function capital U with respect to Z. And the answer here is small u sub n. If we insert a particular complex number, capital Z, into the power series, the resulting values of Z transform of u sub n will be a complex valued function of a complex variable Z. Now, let's go to solving inverse Z transform by partial fraction method. First, let us show this table. We have here the forms of the rational function. Opposite here are the forms for the partial fraction. On this topic, this method consists of three general steps. Step 1. Translate the given function into capital U of Z all over Z. Step 2. Decompose capital U of Z over Z into partial fractions. Step 3. Multiply the resulting expression by Z and then invert the same. Example 1. Find inverse Z transform of the fraction 2Z squared plus 3Z all over Z plus 2 times the quantity Z minus 4. Step 1. Let us translate the given function into capital U of Z over Z. In this problem, the function capital U of Z is equal to this fraction. Please observe that in the numerator, there is a common factor, which is Z. Let us factor that out. From here, let us multiply this equation by 1 over Z. It will result into this. The left side is now function U with respect to Z over Z equals this fraction. Take note, our numerator now is 2Z plus 3. We are now able to do step 1. Let's proceed to step 2. Decompose the function U with respect to Z over Z into partial fractions, meaning the fraction here is equal to A over Z plus 2 plus B over Z minus 4. This is our equation 1. From here, let us multiply by LCD. Remember that the LCD here is the denominator of the fraction of the left side. Multiplying by LCD, the resulting equation is here. 2Z plus 3 equals A times Z minus 4 plus B times the quantity Z plus 2. Let us now solve for A and B respectively. Since this is an equation, we say that the equation is true for all values of Z. Let us now solve for A, which means we must eliminate B. Take note here that we have the B with factor Z plus 2. So to eliminate B, we set Z equals -2. Let us now substitute -2 to all Z in this equation. Then we will get the value of A, which is 1 over 6. Then let us solve for B. It means let us eliminate A. The A here has factor Z minus 4. Let us now set value of Z as 4 so that we can eliminate A. We will change all Z by the value 4 and we will get the value of B as 11 over 6. From here, let us substitute the values of a and b respectively in equation 1. Then we go back to our u of z over z, which is equal to these partial fractions now. Let us multiply this equation by z and simplify. By doing so, the left side becomes capital U of z, which is equal to 1 over 6 times z over z plus 2 plus 11 over 6 times z over the quantity z minus 4. At this point, let us copy again our given problem. Let us now use the partial fractions to represent our fraction in here. So it becomes like this. On the next step, we will take the inverse z transform of each of the fraction. While for the constants, we will put that in front of the inverse z transforms respectively. Remember that we have this formula for z transform of a raised to n, and that is equal to z over z minus a. In reverse, we have now this inverse z transform of the quantity z over z minus a. And the answer is a raised to n. Using the formula here, we will get the answer in our equation here. For the final answer, we have this 1 over 6 times the quantity negative 2 is raised to n plus 11 over 6 times the quantity 4 raised to n. Example 2. Find inverse z transform of z squared minus 20z all over the quantity z minus 2 times the quantity z minus 4 times the quantity z minus 6. Step 1. We translate the given function into capital U of z over z. Our u of z is equal to this fraction here. Take note that there is a common factor in the numerator, and that is z. We factor it out, and from here, we're going to multiply the equation by 1 over z, so that the left side becomes u of z all over z equals the numerator on the right side becomes z minus 20. Then we copy the same denominator. We are able to do step 1. Going now to step 2. We decompose the u of z over z into partial fractions. So the fraction here is now written as a over z minus 2 plus b over z minus 4 plus c over z minus 6. This is equation 1, and the next step, we multiply this equation by the LCD. Remember again, the LCD is the denominator of the fraction on the left side. Multiplying this by LCD, this is the resulting equation. Let us now solve for A, B, and C respectively. We say that this is an equation and this is true for all values of z. Let's begin with solving for A, which means let us try to eliminate B and C. Notice that for the variables B and C, they have common factors, and that is the z minus 2. What we're going to do, we set z equals 2, which means for all the z we see in the equation, we will replace by 2. Then we can solve for A. And the A value is equal to negative 9 over 4. Next, let us solve for B, which means we will try to eliminate A and C respectively. Notice here that the variables A and C have common factor, and that is the z minus 4. So what we're going to do, let us set z equals 4. By doing that, we will get the value of b, and that is b equals positive 4. Next, let us solve for c, which means let us try to eliminate the variables a and b respectively. Notice that there is a common factor for the variables a and b. The common factor is the z minus 6. Let us set z equals 6 so that we can solve for c. And the value is now negative 7 over 4. After completing the values of a, b, and c, we will now substitute here in equation 1. So equation 1 becomes like this. Next, let us write again our u of z over z, and that is the equation 1 here. Next thing is, let us multiply by z and simplify. By doing so, the left side now becomes u of z alone, and the right side becomes like this. Next, let us write again our problem in here. Then let us represent our fraction using our partial fractions. After that, let us show that we're going to take the inverse z transform of each of the fractions. Also, we're going to put the constants in front of the symbol z inverse. So it becomes like this. Now, we're going to use our formula to simplify the z inverse transform. And the final answer is negative 9 over 4 times the quantity 2 raised to n plus the constant 4 times the quantity 4 that is raised to n minus the 7 over 4 times the quantity 6 that is raised to n.